Hi everyone, in this video we are going to discuss about similar triangles and the criteria of triangle similarity. So, what are similar triangles? Well, similar triangles are those triangles where the three internal angles of a triangle is equal to the corresponding three internal angles of another triangle. Even though their size may be different, but their shape would be similar. Their shape would be similar, but their size, meaning their area or how big or how small they are, their size will be different. Meaning, one of them could be smaller area, another one could be bigger area. However, their shape would be kind of similar, and all the three angles of one triangle would be equal to the corresponding three internal angles of the other triangle. So those type of triangles would be called similar triangles. For example, here I have drawn a few samples here. So let me show you. Actually, I have drawn a couple of samples here. So in the first diagram, you see that we have two similar triangles. The smaller one inside the triangle ABC, and then the bigger one outside the triangle PQR. Now both of the triangles are similar because angle A and angle P, they are same. Angle B and angle Q, they are also same. Angle C and angle R, they are also same. So you see the three internal angles of the smaller triangle ABC, those three internal angles actually are equal to the corresponding three internal angles of the triangle PQR. Because the angles are equal, even though their size is different, because the angles are equal, you see their shape is also looking similar, right? They both look similar, just the size is different. One is bigger, one is smaller, but their shape is looking very similar, and that is why they will be called similar triangles. So for two triangles to be similar, one of the criteria that we have learned so far is that the three angles would be equal to the corresponding three angles in the other triangle, right? So when we say corresponding, we have to remember that whichever is the first angle, suppose let's pick A and P to be the first pair of angles, right? And then if we talk about B from the little triangle, then we also want to compare that with Q of the bigger triangle. We do not want to compare angle B with angle R. So if we want to compare angle B, we have to compare angle B with angle Q, and if they are equal, that's great. Similarly, we want to compare angle C with angle R, and if they are equal, then guess what? Then both triangles are pretty much equal, because you already assume that A and P are equal. So if A and P are equal, B and Q are equal, also C and R are equal, then both triangles are similar triangles, right? And again, the triangles don't have to be one inside another one. They can be separate like this. Like I have the second pair of triangles here in the smaller diagram here. There you see we have a small little triangle which is triangle ABC, and then we have a little bigger triangle which is PQR. In this case also both triangles will be similar if the three internal angles of ABC are equal to the corresponding three internal angles of PQRs. For example, if A is equal to P and B is equal to Q and C is equal to R, I mean those angles, right? If those angles are equal, then yes, both the triangles will be called similar triangles, even though their size is different, but their shape is pretty similar. They look pretty similar, just that their size is different, right? So those type of triangles would be called similar triangles. Now we are going to discuss about the various criteria based on which we can decide whether two triangles are similar or not. So the first criteria is like this. So as we have already discussed so far, that if two triangles have equal corresponding angles, then they would be called similar triangle. So in other words, if we have to figure out whether two triangles are similar triangles or not, we can apply this criteria. We can say, okay, the criteria would be angle criteria, meaning the first angle of the first triangle would be equal to the first angle of the second triangle. Second angle of the first triangle would be equal to the second angle of the second triangle, and then third angle of the first triangle would be equal to the third angle of the second triangle. So if that is the case, then we can clearly say that the two triangles are similar triangles. And also sometimes, we really don't have to go for three corresponding angles. We could even go for two corresponding angles, because guess what? If two pairs of angles are equal, then guess what? The third angle must be equal, because the sum of the three angles is 180 degrees. So if I have angle A plus angle A is equal to angle P and angle B is equal to angle Q, then guess what? Angle C must be equal equal to angle R, because the sum of ABC would be 180 degree. Similarly here the sum of PQR angles will also be 180 degree. So if A is equal to P, B is equal to Q, then definitely C will be equal to the angle R, right? So whether you say AAA criteria, or sometimes we could even say that this is like AA criteria. If two corresponding angles are equal, then definitely the third angle will also be equal, and then obviously both the triangles will be similar triangles. Now let's talk about the second criteria. The second criteria says that if we have two triangles, for example in this picture right here we have triangle ABC and PQR, and if we have two corresponding sides of same ratio and one pair of corresponding angle equal, then both triangles would be similar triangle. For example, from this picture I can say if the ratio of the length of AB and PQ is equal to the ratio of the side length AC and PR, and also if the angle between the two sides, which is the angle A, is equal to the angle between the two sides in the bigger triangle, which is angle P. So if we have the angle between the two sides, the angles are equal and the sides are in the same ratio, that means here we can say AB, the length, AB, when I say AB, it's actually the length. So AB divided by PQ is equal to AC divided by PR. The corresponding pair of sides, they are in the same ratio, and angle A of the little triangle is equal to angle P of the larger triangle. If this condition satisfies, then also we can say that both triangles are similar, meaning they will have all equal angles and they will be similar. This is another criteria based on which we can also determine whether two triangles are similar triangles or not. Now let's talk about the third criteria. The third criteria says that if we have two triangles where pair of the corresponding sides are in the same ratio, then we can call both the triangles as similar triangles. For example, in this particular picture, if we have AB divided by PQ, this ratio, the AB to PQ, this ratio, right? Same as BC to QR ratio, same as AC to PR ratio, then both triangles will be similar triangles. So let me first write it down. So if we have two triangles like this where AB divided by PQ, this ratio is equal to BC divided by QR ratio is equal to AC divided by PR. If the corresponding sides are in the same ratio, then also the two triangles will be similar triangle. And this is very important. I need to highlight this. This particular property of similar triangles will be used in coordinate geometry, trigonometry, in many places in mathematics, and this is very important to remember that if we have two similar triangles, then their corresponding sides will be in the same ratio. Now I'm going to show you a couple of examples where you will see that how we can create similar triangles. So we begin with one triangle and then we'll show you how to create a similar triangle, right? So suppose we have a triangle like this. Suppose we have a triangle ABC, and now we're going to draw a parallel of the BC line or the BC side, right? So we're going to draw a parallel line which will be parallel to the side BC. So suppose the line is like this. So we have drawn a parallel line PQ which is parallel to the side BC. Now let's see what happens. So now we can see there are two triangles there. One triangle is the smaller one, which is triangle APQ, and then also we have the original bigger triangle which is the triangle ABC. Now let's see if these two triangles could be similar or not. So let's do a little bit of angle analysis. Now if you see that because PQ and BC, they are parallel, we can say the corresponding angles right here, this angle, the angle P right here, or rather angle APQ, that angle would be equal to angle ABC, because if you assume that AB line is a transversal for the two parallel lines, then angle APQ and angle ABC, they will be corresponding angle, and corresponding angles are of same size, they are equal, right? Similarly, this angle Q right here, or the AQP, this angle, and the angle ACB, if you assume that side AC is a transversal between the two parallel lines, in that case you see that angle AQP and angle ACB, they are also equal. And guess what? The two triangles here have a common angle, and what is the common angle? Well, angle A, that is the common angle. So now you see that we have two triangles which are triangle APQ and triangle ABC. Their corresponding angles are equal, right? Because angle A is common to both triangles. So that is equal between both triangle, and then angle P and angle B, they are equal, and also angle Q and angle C, they are also equal. That means these two triangles have equal corresponding angles. That means these triangles are similar triangle. Now we can write it like this. When we say similar triangle, we can say, okay, triangle APQ is similar to, this is the sign we use, we can say this is similar to triangle ABC. So this is how we indicate that two triangles are similar. This is the symbol used for similarity. Let's take another example how we can create similar triangles. In the second example, we have a right triangle ABC, where the right angle is the angle ABC, which is the B angle. That's the right angle originally. And then what we have done, I have drawn a perpendicular onto the hypotenuse. So BD is a perpendicular going from B to D, and it's making a right angle there also. So it's a perpendicular on AC, which is the hypotenuse of this original right triangle. So now you can see there are actually three triangles. There is a triangle ABC, the original big triangle, and then we have two small triangles. We have triangle ABD, D as in David, and then also we have angle BCD. So there are three triangles, and we are going to show you one very interesting thing here is that all three triangles will be similar. Now I'm going to show you how they will be similar. Let's say our angle A is of the size, say let's call it alpha maybe. Let's say this is alpha degree, right? Angle A is alpha degree. And then let's assume that angle C is beta degree. So I'm going to indicate like this. Say suppose angle C is suppose beta degree. And of course angle B in the original big triangle, angle B is 90 degree, that I have denoted right here. Angle ABC, that is 90 degree. And similarly in the little triangle, the angle near D, those angles are all right angles. Angle ADB, that is a 90 degree. Similarly angle BDC, that is also a 90 degree. So now we are talking about these three triangles, the triangle ABC, ABD and BDC. Right? For triangle ABC, we can say that alpha plus beta is equal to 90 degree because it's a right triangle. It already has another 90 degree angle. That means these other two angles would be total equal to 90 degree. That way the total amount of internal angle would be 180 degree. Now let's talk about the triangle ABD. So now I'm going to talk about triangle ABD, for example. So if you look at triangle ABD, we can say, okay, alpha plus the angle ABD, that will be equal to 90 degree because angle ADB is already 90 degree because I have drawn a perpendicular onto the hypotenuse. So angle ADB, that is already a 90 degree angle. That means alpha plus this other angle, the angle ABD, that sum will be 90 degree. And here you see alpha plus beta is equal to 90 degree, and here you see alpha plus angle ABD equal to 90 degree. That means from these two equations I can clearly say that angle ABD is definitely equal to beta. So I'm going to write it down right here. So this is actually beta angle. This is actually same as the beta angle. Now let's do the similar thing between the original triangle and the triangle BCD. So now for BCD, from here we can say, okay, as you can see for BCD, can we say that angle CBD plus beta is equal to 90 degree? Because angle CDB is already a right angle. We have drawn a perpendicular onto the hypotenuse. So angle CDB is a right angle. That means angle C and this little angle B right here, their sum will be 90 degree. And now guess what? Alpha plus beta is 90 degree, and here I have something plus beta is 90 degree. That means this something must be equal to alpha. So from here we can say that our angle CBD, it must be equal to alpha. So I'm going to write alpha right here. So this angle must be equal to alpha. Now you look at all three triangles. You see that each of the three triangles, they have a 90 degree angle and another angle as alpha and the third angle as beta. That means their corresponding angles are all matching, right? They are all equal. So corresponding angles are equal. That means all those three triangles, they are actually similar triangles. They will be similar triangle. So therefore we can say that triangle ABC is similar to which one? It is similar to triangle ABD. So we can say it is similar to triangle ABD, and that is again similar to the other triangle which is BCD. I hope everything made sense so far. Thank you for watching. See you in the next video.